All right, the objective is to calculate the forces that are acting on a submerged object. So let me define the top of the liquid with a line and our little interface symbol here. So above that, the pressure will be atmospheric pressure, and below that, we'll assume there's a liquid where the pressure builds up as we go down with depth. For the purposes of this problem, I'm going to assume that there's a two-dimensional object that's basically a planar object that is where essentially one of the planes is parallel to the arrow coming out of the paper, and the object can really be any two-dimensional shape. Let me define a center of gravity for that, or equivalently a centroid that exists for that two-dimensional object. And at that centroid, I will define a coordinate system with an x and y axis. You'll see why in a second. I'll also need to define where that centroid lies relative to the liquid air interface. And so I'll draw a secondary coordinate system that comes down, and I'll give the coordinates for that I will call xi. And xi sub cg will be the distance to the center of gravity measured at the same angle that the object is turned to. Define some sort of shortcut abbreviation. So anything that I write as CG will refer to the center of gravity. So that's that little symbol in the center of my 2D object. And then I will define something called the center of pressure, which is where I think the resultant force, so like where all of that pressure integrated over the area actually acts if you were to bunch it all up. And that's actually defined. First of all, I'll define that position, the center of pressure, relative to the center of gravity. And what I mean by the center of pressure is that the resultant force times the moment arm defined by the center of pressure, so that whatever that distance is, will give me the same moment as the integrated pressure distribution would have over the object, with the moment arm being defined relative to the center of gravity.